Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the NPTEL course on Remote Sensing and GIS for Rural Development. This is week 10, lecture 5. In this week, we have been looking at different platforms, remote sensing platforms and remote sensing derived data for NDVI. NDVI has been a very strong indicator for assessing the vegetation health and crop acreage, number of times the land has been cropped or net irrigated area, and it is at a very high resolution compared to the observation data, both spatially and temporally. So instead of getting data for once a year with a big lag time, here we are getting data within a month and at 15 days intervals. So in the past, we have looked at Bhuvan's data sources, NASA's data sources, Google Earth Engine's database. And now we will look at one more aspect of NASA and then look into Sentinel Hub. So in the past, as I said, Bhuvan data is good for the Indian regions. It has some spatial and temporal issues in terms of resolution. It is limited to 2021, whereas we are in 2023. So approximately a year and a half lag time can be noted. Whereas Google Earth Engine catalog gives you data for within a lag month, 1 month, which is you can get also data from Jan, Feb. How we are in March, so March 2023, you can get it for Jan and Feb. And NASA's USGS focus mostly on the NASA data that is available, and we also have the Sentinel, which is the European Space Agency ESA data set. I will go through the other part of NASA's visualization and analysis tool, which is very important for understanding the groundwater and NDVI issues. So without further ado, I will open the GES disk webpage. So we have completed the NASA Earth Explorer, but while I was showing how to download data and access the data, I also wanted to show some parts of the NDVI data that another portal can give, which is the Giovanni. So I'll continue again with the Earth Explorer. So I'm going to click this and open the Earth Explorer page. So in the Earth Explorer, we said that we have all these data sets that are available for NDVI, and then we can download it as marking and done. But in the GIS disk database, what we noted is if we do NDVI and then put our bounding box on India, the default date can be given, so you don't have to put a date. You can just click, and then these two data sets come up. In these two data sets, we clicked on the first data set and went into online archive. So the online archive, as we said, we looked at the different folders, and within the folder, there's multiple data sets. If you wanted to know how to download it, we can also read these links. Then you can also get data. It will ask you what type of data you want and then define the data range, etc. So it says download method is get original files, and then you can define the range. So let's just do a quick 2015 is the max they have for this type of data set. You could see that these are all blacked out. There's no data. So Jan 2016, you can have 30th December, you can have, or 31st December. That's fine. Okay, so we have the whole of 2015 data. It's just for the sake of this exercise, we'll do it. And the file format is only HDF. Okay, so this is the get data button. You don't have to go through the download HTML and stuff. Okay, so if you say get data, what it does is it runs and talks to the database in the US and brings all the data to this page. And you can see that the monthly data has been there. Instead of going to each folder and then clicking, you can also do this as one. So if you just click it, it will ask you to log in and then get the data. The login is to just show how much people use the data, etc. The file lists are valid for 2 days. Suppose you have slow internet and bandwidth, you can still have this page in your login. You can go to the login and download data sets, and then this will be there. So the link has been created automatically for you. It says if you have already account, create an account, link this GES disk to your account, and then download. Download the list of links, or how to get widget. Widget is again an automated process for getting the data. It's kind of advanced. Let's not go into that, but download the list links. So this is the list links that you can download, and then it's a text document. It will give you the link for downloading the data, okay, with your login. So that is the download instructions, and download list is there. So these are the list links and stuff. And what are the parameters you wanted to select? You wanted the MODIS vegetation indices. So the both indices are there. The vegetation fraction NDVI is there. And then the date range you have given as 2059 to 2015-12. That is what it gives. So you can refine and re-download it and then get the data. Okay, so this is the one way of getting it. So 3 options are given: online, archive, where you go to the folder, you download it, get data is also there. The Earth data search is also good. The Earth data search opens the dashboard at once. And in the dashboard, it has already searched for you because it is linking to the GES disk database, this database. So what it happens is from here, it has linked the data to the Earth data search box, and that particular refinement is not there, but you can still get it. So this is the data set. And so there's one match for your data set, which is NDVI, and for your particular link. However, you could see that the date is still at 2000 to 2015. So you'll need to refine it. Okay, you can click on the metadata to see what the data is about. So this is the version 5, and then the data is given for the whole globe, and then some other keywords. What is the format, HDF format, etc. Okay, so you can go back to your search and then say I want to download. So this is to add collection to the current project. You can add the collection and then it will be there in your account for download. My project, my download. Okay, so but before that, let's also show how this can be used. I am going to say I just want NDVI, and then a lot of NDVI is coming. And then let's say I'm going to press enter. It will show you what are the Earth data search database tags with NDVI. So one thing which is clear is coming out is that there are multiple databases saving the same data or process data in online versions. All of these are open source. All you have to do is just click on a particular link and get the data if you have the login credentials. So here what we are seeing is there are features available from the cloud, customables or map imagery, instrumentations, platforms. Do you want airborne platforms or land-based platforms, space platforms? Let's say airborne. Air-based is mostly the hyperspectral from a drone and other imagery. And then very, very small lakes. For example, Big Trail Lake is done using the drones, and very, very small area coverage is there. Okay, so if I just take it, so here you can see jet propeller, unmanned vehicles is also there. See here, click it, and then click it. You can see jet, propeller, uncrewed aerial vehicles, or unmanned is also there. So the UA, however they want, they can use it. Unmanned aircraft vehicles or unmanned aerial vehicles. And here they say another term which is new also for me, which is the let me see if we can read it. It's not coming up. Let it come up a bit. Yeah, so it says uncrewed. So unmanned and uncrewed people not there, that's all it says. Okay, so these are different platforms. I'm going to click all, so all the platforms can come up. So you see all platforms are there. Instrumentations, which sensor, which satellite sensor you need, camera center, multispectral, hyperspectral, and all the systems. And then organization is at NASA. NASA is there, Oak Ridge National Laboratory, processing levels, and then projects, if it is particular projects, NASA's project, data format, HDF, all the formats are openable in QGIS. So that is the beauty of using the open source system QGIS. All formats can be opened or converted. So you can readily convert these formats in QGIS. I haven't seen that strength in proprietary softwares yet. Latency is how delay you want the data, 1 to 2, 3 hours is there, and then you can use it. So for example, you can click the 16-day gridded data, just click on it. It will show you how many grids are there for every 16 days. And then you can download every data set that you want. You don't have to download all the 1,400 data sets, because this is 15 days. And then sometimes they'll double duplicate data. So this is from 2023 to forever. So 2023 is still going on, right? So what we could do is you can actually filter by date. So here you can put the date. Let's say I'll put November 1st to December 2021, December 31, and then apply. And so now it's going to get recessed. So now from 148,000 to now 42 collections, which is good, manageable. You can download each one. So you just add it to your download page, or you can just quickly download it after you have the, so it's just populating the link, and then it will let you download the file. Okay. So as I said, you can download the file after you have the login, and that is what it's asking, your login passwords and stuff. Okay. So you do have to have an account. So make sure you create one account pretty soon for this database. So there is a lot of data that could be taken up for NDVI. And one more thing I would like to show is a ready-made product where you could do some quick analysis. Okay, so let's do visualize data. If you click on visualize data in GIS disk thing, it opens as Giovanni. You can also go to Giovanni, just this link, it will take you there. Giovanni is an application. Okay, let's see if we can redo that again, because there is a note which comes up, says it what it is. So this application allows you to visualize the parameters, and you can have a help page to look at how to do it. I'll quickly do this, but you can definitely read it for your future understanding, and then you have to have a login. Okay, so let me close this here. You can hear this is the type of analysis you can do. You can do a time average map, time average overlay map, map accumulated, comparison between two maps, selected area average, time series averaged, etc., etc. So this is a analysis type. So let's say time average map, or time series. Let's say time series area averaged. Yeah. And then we're going to say that I'm going to have 2022, just to make sure the data is available. We'll just say first Jan to, you don't have to put the time is not needed, to 2022 December, okay, December 31. And we're going to say the bounding box. I said the numbers for India. If you don't remember it, it's okay. We can just use the box and then click the box. The box symbol is different here. So you can just say it's around 64, 63, 40, 100, and 4. Right, so 64, 63, 4, 5, 9, 198, which is 100, and then 40. So you can click this box again, and this is select a shapefile. If you have a shapefile, let's say for India, Maharashtra boundary, you can add it here, and then you can do this. And here, as I said, you can type NDVI, and it has come up NDVI, and then it says search. So when you click search, all this will come into account. So from 1 year time period for the India platform, this data is coming up, and it has monthly resolutions of 0.05 degrees, 2002 to Jan. As I said clearly, Jan Feb data is still getting populated, so which is very, very good. So we are now in March, mid-March. So within 1.5 months, you have the data. whereas you don't have to wait 1.5 years in other data sets, right? So you could, is 12 months exceeds the maximum number, 4 can only be processed. So we'll have to reduce it. We can reduce it as monthly. So monthly is 12. So it says 12 months you have selected, we can only do 4 months. So let us reduce this time now from, let's say May to, so that is the monsoon period, to May, June, July, August. So we can do August, right? May, June, July, August. So 4 months. And then it populates the same thing again. And now it says, okay, guest limit. We are a guest, so we can only do this much. And if you have an account, you'll get more. So this is what I'll be clicking on to understand what this data is. Okay. So if you want to read the metadata about the data, you can click the link. It will open here. And you do have a good analysis of vegetation derived from a model, and then multiple types of vegetation indexes. You have greenness fraction, leaf area index, climatology, etc. Okay, so once we have this begin date, end date, you can say plot data. The plot data will plot the data. As I said, we needed time series area averaged. So it is now running. You can see it is running. It is not using your computer's memory or software. You're given the code. So when you click the boxes, automatically the code is developed and sent to the NASA's computers. And there it is actually processing. So this processing is there. So your internet speed and your memory power does not get affected. So here you are. Analysis for India scale. It just took 10 seconds. Maybe my internet was fast. The uploading and downloading is fast. I just checked the upload download speed before we started this class. Mine is pretty good, but in a normal situation using your mobile internet, Wi-Fi, you can get this within a minute. Okay, so you could see here from May, the NDVI is increasing. That is what it says. The unitless NDVI doesn't have units, and it starts from -1 to +1. The time series average of NDVI for the entire India at 0.05 degree resolution. Everything is given here. You don't even have to type this in your reports. But you did it because you actually plotted it, the boundary, and you said this is the time series, this is the NDVI I want to see. And this can be done. This Giovanni can be used for multiple parameters, not only NDVI. I'm only showing NDVI because this week is linked to NDVI. So I'll be showing this. So you have different options. You can show the title, show the caption, or remove it if you want. But let's keep the title, let's keep the caption, which is here. The user region was defined as this is this, which is India. India boundary. If you can take the lat longs of this and put it on the lat long calculators, you can see it is India. And then the visualization results. You can download this as an image. The data can come as an image. You could see that the time series average, area average output was taken. So for the entire India, all the pixels, to do this, it takes a lot of computing power. But you have done it within a couple of seconds because of the supercomputers linked to NASA. So beautifully, you can explain that, oh, from 1st May, 1st June, July, and August, the NDVI is increasing. That is because most of the monsoon happens here. So in Maharashtra, the monsoon onset is June, let's say June 1. And then June 6, the first week. So June 6, normally it comes. So you can see that after that it peaks, starts to peak up, and now the plant is growing healthy well. So let's do another one. Let's do Jan, Feb, March, April to see how it comes back down. And then you can say back to data selection, and here you can go to let's say 2 Feb to 5, 2, 3, 4, 5, 5, and then I'm just going to go to results. We'll go to the original results. I'm going to plot data. So when you do plot data, so the previous exercise is here. You can see that input, plots, download in lineage, everything is there, but we'll keep it out for now. This is the history. And now our other file is downloading, getting access. Successfully ran the time series average for the entire India within 10-15 seconds. And now you have this. So can you understand this? Now what's happening is initially the winter crops were slightly growing. There was irrigation happening. And after irrigation, it plummets. It shoots down because of people harvesting it, and the summer kicks in March. So you see from February, March, April, May. So May slightly there's another round of irrigation because a lot of people do some groundwater irrigation, subsistence farming, etc. And there's some other summer monsoons in some region. To reduce this, what you would do is go back to data selection. You can go up and just put a bounding box near, you can zoom in. Okay, so let's zoom in. And then, oops, I'll take this box out. You pick this hand, and now you can move. Let's say you want this Maharashtra region, this part, this style is enough. Let's say this style is enough. So I just draw a box here. Okay, and then I close this map, and NDVI is fine. The data range is that, and then let's say plot data. So this is the third time series we are doing. That's why I'm saying 3. Again, this I'm not using GIS, but when you download this time series, this is an analysis, this is a plot. You can actually put it in your reports. If you want to do it from scratch, you will have to download it. So if you take Maharashtra region, you see how it goes really down. So for my region, I know there is no summer monsoon. There is only really drought at that time. So it just goes down. There is no, even irrigation doesn't happen because there's no water. Groundwater is going down also. So when you take the entire India, it's a different ball game. Like for example, this one, the entire India is different. Okay, let's click this one for analysis. So we have the same time frame for entire India. It starts at 0.33 and then comes down and then goes up. Whereas for Maharashtra region, it is just going down. This is purely because we do not have a monsoon in the summer. It comes only in June. So until then, it's just really dry region in that part of the world. So you can download the data, etc. You can change the type of results analysis you want. If you don't want time series average, you can see a time series map. So now what you're going to see is a map for that area. I'm going to say plot data. So this is not a time series data. This is not points, but you're going to see a map. Takes a little bit more time because you are launching. So look at what it's saying. It's launching the work, attaching the data files in the cache from here to there, and then doing the time average map. It takes a little bit more time because now you're going to see a map that's going to come out. Successfully ran the image. Now it's computed. Visualization is being created. So this is the GIS step, right? You'll do the analysis, you do the visualization, and then you plot it. And all of this is done for you automatically. There you go. So this is the region we said, right? And in this region, so the entire thing is averaged to one value in this time series. This is an average of this. But now if you see, it is every pixel in count, right? So every pixel is taken. You can zoom in to see the pixels and where the green color is. You can download this as a GeoTIFF. In the previous download, you only see image, but here GeoTIFF, KMZ, PNG, NetCDF, all these are usable in GIS as a raster. So now it's a raster data, you can download it and then put it up in your database. So again, it will ask for your online link for downloading the data, but make sure you have the link already when you start. Just log in and start. So this is about Giovanni. As I said, you can use multiple data set. All this will be stored in the cache memory, and once you go to a new page, all this will be deleted. Okay, so all the history will be deleted, and this is really cool analysis that you can do within a couple of seconds. The units would be different here. You can see that 0.39 to 1, whereas here the units are different. But again, as I said, there's a scaling which needs to be done. You'll have to look at the data, what is the range, and then scale it. So the value is -1 to +1. It cannot go above and beyond that. So this is a scaling that they have used. Okay, so I would recommend using the Giovanni. You can go to back to data selection. You can collect different disciplines and then do the same thing. If not NDVI, you can say vegetation fraction. You can say measurements, what type of measurements you want. Let's say soil moisture. You can do soil moisture also. Soil moisture is there. So if you know soil moisture is very high, you don't have to irrigate. So that is the understanding of soil moisture. And for that same location, we can say that this is soil moisture percentage at 25 kilometers, pretty large compared to the NDVI. And then it will give you at different depths also. Okay, so you can say at 0 to 40 to 100 centimeters depth. So 0 to 10, 10 to 40, 40 to 100, 100 to 200. So 200 centimeters is divided into 4 data sets and then given. This is also meter cube by meter cube. So it's kind of, you can say unitless, but normally people express it as meter cube by meter cube. Let's say 0 to 10%, which shows the initial part. Okay, this is daily, right? So you can see here that the soil moisture data that we clicked is daily, and it says only 4 days you can click. So let's see what data range they have. You can see that the most recent one is 2016 for that data. Is that correct? Yeah, it has 1979 to 2016. So it stops at 2016. So we cannot use, if you want, you can use it. But I would go for more 2023 data so that we can have some soil moisture. So there's a soil moisture 2011. You can limit the data here in temporal resolutions, monthly, spatial resolutions, etc. Right. So these are 2022. So 2022, yeah. So this we can do. So 2022 November is available. Let's click this one and unclick the other one. Yeah, that one unclicked already. And then let's say date. It cannot have so much date. So we'll have to say 2 and then only daily, right? So daily, you can say these are the 2 data sets and NDVI I'm taking out. So yeah, let's pick a date and plot data. It will plot the data within February, whatever data is available, and then plot the maps for that particular thing. So it says scanning data for that particular data set. Giovanni is very, very important for understanding different sectors. So now you could see that this is 100 to 200 centimeters underground soil moisture value at 25 by 25 kilometer grid. So this is pretty big, but it's pretty useful because these are based on ground penetration data. So even if you have this, you can tell the district collectors that if there is need to be water released or groundwater is going to be used, can be told by these images. So with this, I will stop the Giovanni exercise and NASA exercise. From US now, let's go to Sentinel Hub, as we discussed in the slide. So this is the link that we will be using, the Sentinel Hub. So we're going to go to the Sentinel Hub now by opening a new tab. So from here, we go to Sentinel Hub, okay, sentinelhub.com, which I've given the link in the presentation. So it says a cloud API for satellite imagery, and you can use for Explore Hub, request a trial. You can go to the Explore the Hub part. So here is the what the data is about. I would like you to take you to the EO Observer, which is the Earth observation browser, and all these data sets are there. What data is available, etc. We'll just jump into the data section, and you can see that there is Sentinel, which is European, Landsat, NASA, commercial collections, DEM, Copernicus, again, a service database from Europe, MODIS, NVSAT, US, etc. So you can also bring your own data and then do it. So we'll go back and then launch the Explorer. EO Explorer is what we need to open. Please note the browser extensions, etc. So you can accept the I will not use the tutorial. So just go here and then use it. Okay, so here we have already done a couple of exercises, but let's see what we want. You can say that you want these are the different indicators you have. You have agriculture, vegetation. Let's go to vegetation. In the vegetation, you see certain data sources that are existing, and up to 2023 19 March, which is kind of today, where we are doing the range. We can say February to March is good, and that is the data that is available. So you can say advanced search for Sentinel, etc. Or we can say agriculture, and then agriculture is only Sentinel-2, and then we can get this data. So commercial data is also available. If you want, you can sign up and then do it. You have to pay for some of it. And then highlights is what agricultural regions, then recent news articles they have written, published using this data. So let's go to search, and then this data fine, we will just search. Let's see how much data we have. So this is 19th of March we are on, and you can see this is just 3 days ago this image was taken. And you can already access it here. So this is very, very interesting and cool because, okay, before that I should have done Pune just to keep it in Pune, Maharashtra. Yep, so we are in Pune. So you can see Pune is coming when you click Pune, Maharashtra. Okay, so Pune region. Okay, let's say Sangli. Sangli, why? Because it has a lot of sugarcane. So you can see the NDVI for the sugarcane, right? So until now, now we are on Sangli. Okay, so you can see that these are the other tools that are available. You can also do the plot as we did in Giovanni. You can plot the data, but first we have to select the layer. So here we have 26 data sets based on the data date. And look at this, you have already cloud cover. So would you use it? We don't want to use all these cloud cover data. So normally the best data sets are coming on the top. So we will go to back to search and then search now for Pune, Sangli region. So now the data is getting updated because Sangli we didn't type initially. So now Sangli, and we have around only 5 results. And this is good. This is really good because March 10th, this data has been taken. So let's do visualize. And so the Sentinel-2 data has been visualized. Again, Sentinel-2 data has multiple bands. Okay, and this true color is made of only the 3 bands, 4, 3, and 2, which is giving you the true color. And if you want, we can look at what are the bands, Sentinel-2 bands, and then you will see a list of the bands in Sentinel-2 that are available. So Copernicus is good because that is where the European Space Agency is having. And then you have all these, Sentinel-2 has 10 spatial resolution bands, B2, B3, B4, and B8, etc. And then 20 meter spatial resolutions. These are the other 20 meter spatial resolutions. So some bands are high resolution, some bands are low resolution. So the 10 meter spatial resolution is B2, B3, B4, B8. B8 is kind of your red. We'll check what it is. And then your 20 meter is multiple bands, and then you have these bands also. So you can see here, it is given here as B8 is, if we can zoom in, that would be great. Cannot. So B8 is here, B3, B4, B8. So B8 is in the red, visible near red, near infrared, along the red side. And then B2 is your blue, and then all these are visible. So visible is what we can see, WebGR. The WebGR colors we can see, and then the B3 is your green, light green you have, and then the B4 is your orange, kind of red, and then the B8 we cannot see by human eye, and that is your red color. So this is mixed in the composite. So now if we go to the Sentinel Hub, it says 432. So the 432 is 432 are mixed. So red, blue, green are mixed. And then the primary colors are mixed to make this image, which is the true color. The false color is 843. So 843 is a false color. It uses the infrared region data. So 8 data is red, which is the visible near infrared. Some part of it is visible, and that is why you could see the red. It gives you the growing period, growing color, etc. So let's go to true color. You can see all these land parcels. Sangli is very, very known for sugarcane. So you'll see a lot of sugarcane in Sangli coming up soon. and then the indicators. So these are the indicators. You have NDVI, EVI, Enhanced Vegetation Index, the Normalized Difference Vegetation Index, and then the moisture stress. Agriculture is B11, B8, B2. So you can see where the agriculture is happening along the area. And then you have SAVI, Soil Adjusted Vegetation Index. So just by clicking, the NDVI just populates. The metrics, the indicators just populate. And this is the beauty of using the Sentinel Hub. So every platform has its own use and benefits, because they don't want to redo what others are doing. We are more interested in NDVI, so beautifully NDVI comes, and for that particular date, which is just 15 days ago, we are looking at. So let's look at the date. So this is 2023 10, 9 days ago, not even 2 weeks. And you can also say how we can compare. So this is March. And you could see that there's a lot of parcels of land that is being under cultivation. I've been there, so I've seen a lot of sugarcane, literally a lot of sugarcane being harvested. So one thing we can do is beautifully, we can add to the compare. So I'm adding, so it adds to compare. Here also you can do a login, but to visualize as a guest, it's okay. You don't have to do all these things. So you can go to back to search. So one data set we have created. You go to discover, you will take the other data sets. And then this is in February. What we could do is we could realign our back to search, and then say maybe pick a previous date in 2022, let's say November, and then say search. You can say search for the same dates. November 15, right? So say search. And then you get the November months at the bottom. Right, so you have the November months. You can sort it by date or the best data. So this data is good. So all these data have some issues. Cloud cover, some white is there. We don't want that. We can use this color. Okay, so clean image. You can say visualize. The same visualization comes up. Let's say NDVI, and then the NDVI gets populated. And I'm going to add it to the compare. Okay, so compare is we're going to compare live the two NDVI data visually. And then we can download it if we want to download. So free to sign up so that you can download all these data sets. So here we have the compare, and let's say this left side, what I'm going to do is I'm going to keep the left side image. So this part of my computer is going to be my NDVI from November, and this part is going to be my NDVI from current date, March. So you could see that the data set is converting more to green, because during November, you still have a lot of moisture in the ground, soil moisture that contributes to agriculture, and that can be used widely for the sugarcane, whereas groundwater recharge is high. March is almost setting into the summer, so you will have less vegetation growing, and that is what this color difference is saying. Remember, this is the same bands. We are not changing the bands. We are taking the NDVI. Let's go here to see what this NDVI is about. You can see here it is a normalized vegetation index, range -1 to 1. It gives you these colors. And it has been more info is here B8, B4, B8, B4. So B8 is your visible near infrared. So NIR, let's say NIR minus red. B4 is red. It's not orange, it's red color. So B8 minus B4 by B8 plus B4. That is what the equation we've shown in class. You can see here the equation given. Okay. So in the compare, we have seen beautifully the two data sets being compared. And once you have the education mode can also be turned on, where you have better access to some data, and theme also can be done. So I'll take this normal mode. Okay. So in the compare, we have this data set, and you can draw in the search, in the search ones, you can have in the search ones, you can draw and then see where how big the polygon is. Instead of saying Pune, Sangli, you can actually draw, and that box can go in. So it's kind of like a bounding box. You can upload a shapefile to do it. Same like Giovanni, you can upload a shapefile and download the data. and then you can have point of interest, and then other resources. You can also measure and download the image. You can download the image without much problem. You can say you want overlay maps, analytical, you want analytical map is currently only the basic image, so you don't have a high res print also you won't have. But at least you can download the image and then do it in particular formats. You can also animate. All these you have to log in. You do a 3D map, analyze the histograms, colors, etc. So this is pretty cool in terms of using a free open source system without login. I've done to show some people might have some issues in logging in, but it's pretty safe. I do have login accounts. I'll just show you how it is done. So I've logged in now, and now all these come up, right? So you can say that you can have just this area. I want the you can measure the area for a plot, say, okay, 637 meters perimeter, 0.05 kilometer square. You can now download some of the images, georeference or PNG, no georeference is there. And then you can also do it with georeferencing that we have taught in class. Some analytics cannot be done. Okay, let's say visualize, discover. We'll go back to discover. Okay. Go back to search, go back here, go back to NDVI, and now the analytics can be done. So this is basically the area I wanted, and it's just calculating the analysis. So you can see here, the green values are here, and you say there is more green, right? So now if I use a different data set from my previous example, let's say, or you can say just 10, and then let it populate. You will have a better histogram because, okay, it hasn't populated. Okay, these are in the Jan month. So let's use one in the Jan, and then the population comes up. So you can see now a better high green number of greens because it is good for so the on the other side, right? So 6 is green. You'll have a lot of green because there's a lot of NDVI calculated. So this I'll stop. I will see you in the next class with some more indicators. Thank you.